Genetic history. Can the lifestyle choices and life experiences of the generations before us influence our health today? Do we have the power to change those outcomes? Keep listening on to find out, only here on the People Scientist podcast. You are listening to The People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be. Hello, my People Scientist Army, and welcome back to the People Scientist podcast for episode 121, where I arm us with some scientific information so that we can all become a little bit smarter and a little bit healthier with every episode. How is your day going so far? I appreciate you including me into your day today, and I hope I can bring something positive to your day. It's funny, this morning I was standing by the water after my run, and I was thinking, how cool is it that I create some content, that I share my passions and interests, and I put that out there online. And then there are some people like you, yes, you listening right now, that sees the content, that listens to it, and you say, hey, I like this. I'm going to subscribe and keep listening. And I think that is just the coolest. That I put myself out there in the world and as a result created a community of people like you who are interested in the same things. So thank you for listening, and thank you for being a part of the People Scientist Army, for it is you that I put this content out for, and I appreciate your interest and the time that you give to me. So what topic am I going to cover today? Well, I'm interested in this notion of genetic history. That the genetics that we have today may be a result of life experiences and lifestyle choices that our ancestors and the generations before us made. That what we fear, what we enjoy, what we like to eat, how we exercise best, may be a result of choices and things our previous family members were exposed to and chose to do. Can we use this information to help us have better mental and physical health? We'll keep listening on to find out. But before we jump into the core takeaways, let's start off with that new segment I created, Foregone Facts, where I share an interesting scientific finding of long ago. As we are in the month of March, daylight savings time is upon us. And have you ever wondered how this day came about and why? Well, an article in the journal Scientific American published in July 2020 tells us, in 1908, William Willett, a member of the Royal Astronomical Society, proposed to the English House of Commons the concept of daylight savings time. The reason why Willett proposed this? Well, we might think so we can have more daylight for recreational activities, right? For example, right now the sun rises around 6:30 a.m. and sets around 6 p.m. here in New York City for me. In a couple of weeks, when the clocks spring forward, then the sun will rise at 7:30 a.m. and set at 7 p.m., which may provide more daylight during prime hours for many of us. But the primary reason that Willett proposed daylight savings time back in 1908 was to have more daylight during the work hours in order to reduce gas needed for artificial lighting. It was estimated that countries and organizations would save around $15 million in gas back in the early 1900s from artificial lighting and heating and cooling of buildings. What do you think? Do you think that we still need daylight savings time? Do you think that it still saves us that much money in today's world? So there today is the foregone fact. Now let's get into the core takeaways of today's topic on genetic history. Have you ever wondered if we can change our genetic outcomes, or have you pondered why we are the way we are? why we are built a certain way, why we prefer certain foods, why we may have certain fears that we can't explain. While our own personal life experience may shape these things, sure, and I can think that we can all appreciate how our genetics may shape those things too. But more specifically, what our ancestors went through, their life experiences, their lifestyle, even just one generation ago in our parents, may also shape who we are today. These lifestyle choices of our ancestors could be passed down onto us so that we may be similar to them via something called epigenetics. So are we stuck with the epigenetics of our ancestors, or can we change our outcomes? The good news is, it looks like we can change our outcomes. Our genetics are not our destiny. Now, let's get into those scientific details. So let's first talk about what epigenetics is. Epigenetics is essentially how our lifestyle can impact our genes and how they work and how they are expressed. Now, this is a pretty cool concept because we are born with a set genetic code. But with our lifestyle choices, we can change how that code works. We can change how that code impacts our health and behavior. Epigenetics is like the capo on a guitar, making the pitch higher or not. Epigenetics are like the taps of our sink, making the water hot, the water cold, on or off. They're like the regulators, so to speak. Epigenetics is a phenomenon that regulates how our genes work. More specifically, epigenetics can include DNA methylation, histone modifications, and microRNAs. So what are these lifestyle things that can result in epigenetic changes? Things like the foods we eat, if we exercise, if we consume alcohol or drugs. These can all lead to epigenetic changes, or how our genes are expressed and how they work. We understand and appreciate that our genetic code itself is passed down to generations, like if we have children. But what is being realized as of late is that our epigenetic changes can also be passed down. So the choices that we make in our lifestyle, the experiences we have had, may impact the health and behavior of future generations. This might explain why we like certain foods, why we react certain ways, why we have particular fears, preferences, or a certain body type. Charles Darwin wrote that natural selection can act only by taking advantage of slight successive variations, only if organisms can come to fit their environment by minute adjustments. That it never take a leap, but must advance by the shortest and slowest steps. That precise adaptation is possible, and it is thought that over time humans and animals would adjust to their environment for optimum survival. Like if we live in a cold climate, over generations we may become better at producing body heat. This would involve adaptations to the hypothalamus of our brain that regulates our body temperature. This would involve changes to our metabolism and diet-induced thermogenesis, meaning producing heat from the food we eat. Because eating protein is known to induce the greatest increase in body heat out of the 3 macronutrients, do generations of people that grew up in cold climates therefore have a preference for eating protein-rich foods in order to keep themselves warm? It appears that way, yes. Did your ancestors grow up in a very cold climate? Do you think that you have a taste preference for foods rich in protein like meats? That makes me ponder then, what about individuals living in a hot climate for generations? What dietary preferences may they have developed? Perhaps more carbohydrate-rich foods, perhaps salty foods in order to maintain electrolyte balances during bouts of sweating. But now in the last several decades that we have climate-controlled buildings and vehicles, what will this do to our genetics? What will this mean for next generations? We don't know yet. Perhaps food preferences will now be placed less on need for body temperature regulation, but now more so on other aspects. Perhaps like how the food makes us feel emotionally. Perhaps how it impacts our mood, such as developing a taste for sweet things with caffeine, because they are known to release dopamine and the brain reward pathways to induce pleasurable feelings. But we know long-term that high intakes of sugar and caffeine can be detrimental to our well-being, and I talk about that at length in episode 58 if you want to know more about that. So now let's talk about the role of epigenetics from our parents and on our physical fitness, health, and diet. Beliza in 2021 in the European Journal of Clinical Investigation wrote a review on how the physical fitness of our parents can induce epigenetic changes in themselves, which can be passed along to us or the offspring. We know that regular exercise can induce epigenetic changes in metabolism and protein synthesis within muscles, and it appears that these epigenetic changes can be passed down to our offspring. Axum in the journal Physiological Reports in 2019 found that increasing exercise led to changes in how certain genes were methylated, and this methylation was observed in the offspring, but not in the offspring of those that were sedentary. So essentially, if we are healthy and work out at the time of conception, that it is likely that these same metabolic epigenetic profiles will be passed down to the offspring to exert the same beneficial effects on fitness. In addition, many studies indicate that if a mother exercises during her pregnancy, that the child will have a reduced chance of becoming overweight. They'll be less likely to have a lot of fat mass and more likely to have better blood glucose control as they grow up into adulthood. That is versus children of mothers who did not exercise or who were more sedentary during pregnancy. So this is a good sign. For example, if our genetics predispose us to certain negative health outcomes, like if we know that our grandparents had heart disease, then we might be able to influence our genetic predisposition to this disease with healthy lifestyle choices, and similarly change how those genetics are passed down to our offspring. And this is done through epigenetics. What our mothers ate while pregnant may also influence our health. Numerous studies evaluated data from the Dutch famine birth cohort of the hunger winter in 1944-1945. Overall, they revealed that when the mothers were not getting enough food and nutrients during their pregnancy in this famine, that the children born of these mothers would have a higher likelihood of developing metabolic syndrome, including obesity, elevated blood glucose levels, and decreased glucose tolerance later on in life. It is possible that the fetus had to overcompensate, to hold on to fat, to absorb all the nutrients while in utero, and these epigenetic adaptations may have carried on throughout their life. But the influence does not come from just the mother, but the father as well, as shown in the newborn epigenetic study published by Donkin in 2016 and Subri in 2015. For example, paternal obesity altered small RNA content and DNA methylation in the sperm, as well as DNA methylation in umbilical cord blood leukocytes in the offspring of obese fathers. So again, it's possible that these epigenetic associations associated with obesity can also be passed on to offspring. Casper in 2020 in the journal Mammalian Genome wrote of how the risk of developing type 2 diabetes may be inherited through epigenetic modifications from the parents as well. So if the parents unfortunately have poor blood glucose control, that this may be passed down onto the children. These epigenetic changes from the parents may persist in the embryogenesis. And honestly, this is not too surprising, as in hospitals, the rate of type 2 diabetes in very, very young children is escalating quite rapidly. Like 10 to 20 years ago, type 2 diabetes was really only diagnosed and seen in adults. But today we're seeing it in very young children, and typically from parents with improperly controlled type 2 diabetes. So for my science enthusiasts listening, what are these epigenetic changes? Well, they were differentially expressed transcripts, genomic cytosine methylations, and several chemical modifications of the histones. So sadly and unfortunately, parents that have improperly controlled blood glucose at type 2 diabetes might pass on the elevated risk for type 2 diabetes as well. Okay, but it's not all doom and gloom. Let's say our parents were not as healthy. Are we doomed to be the same? Nope. Because we as scientists like to say our genetics are not our destiny. Our genetics give us a target. It gives us an understanding, and therefore that should be empowering. As I said at the start, yes, we are born with a specific genetic code, but epigenetics allows us to regulate how that genetic code works, and it appears to change quite quickly, the epigenetics. So we can make lifestyle changes in order to change our outcomes. So, for example, if our parents were not as healthy, can the potential negative effects be undone? Yes, it appears so. If individuals make the right lifestyle changes with time, they can alter their epigenetic profile to become different and can change their health outcomes. This is particularly effective if done early on in childhood. In this same review by Beliza, they point out that children who are physically active can negate the associated risk of being overweight or having poor blood glucose control. Now, how about the diet preferences and how we metabolize our food? Is that involved in our genetic history too? Yes, it appears that through generations, the climate and the food that people were exposed to resulted in some epigenetic changes too. For example, Fumagalli in the journal Science in 2015 wrote of how the indigenous communities of Greenland showed genetic adaptations to their climate and diet. Had the Inuit ancestors of this population arrived in Greenland less than 1,000 years ago, but they lived in the Arctic for thousands of years before that. These communities in Greenland have lived with very cold temperatures and typically eat a diet rich in protein and fat and low in carbohydrates. The fat content of the diet tends to be high in polyunsaturated fatty acids, coming primarily from fish. So the scientists conducted genome-wide analysis of 191 individuals of the Inuit community living in Greenland. And they particularly made sure that these individuals had less than 5% estimated European ancestry. They compared this to the 60 individuals with European ancestry and also 44 individuals of Han Chinese ancestry. So what did the scientists find? Well, the strongest signal of genetic selection was located within a region on chromosome 11 that included 5 genes involved in fat metabolism, for example, FADS1 and FADS2. The proteins made from these genes are necessary for converting fatty acids into longer-chain fatty acids. Interestingly, they also noted some genetic adaptation of the indigenous individuals of Greenland that they also see in polar bears. More specifically, some adaptations to the genes that counteract high-fat diet-induced obesity and related insulin resistance through increased energy expenditure and enriched muscle and heart development. The same thing that they see in polar bears, and I thought that was so cool. They also noted an association of these genetic adaptations in fatty acid metabolism to height. And they noted a shorter stature and lower body weight in individuals with these genetic adaptations to how they metabolize fat, probably because of the effect of fatty acid composition and concentration on the regulation of growth hormones. Now, that's interesting, isn't it? So living in a cold climate and eating meat and fish rich in protein and fat altered the genetics of this population in a way that they metabolized fat differently in order to protect them from heart disease, to alter their growth hormone, and to shorten their stature. So this is an example of genetic changes itself, changing the genetic code, not epigenetics. So changing the genetic code itself to create SNPs or alleles or genetic variation seems to take time over many, many generations. Whereas epigenetics, right, like that tap on the sink, turning on and off the water, changing how the genetic code works, epigenetics seems to happen much, much more quickly. And we can typically see epigenetic changes within weeks of different lifestyle changes, and sometimes even quicker. So I think the question that we are all thinking again is, can we use this information to our advantage? If we think our ancestors grew up with a certain lifestyle or climate, can that information benefit us? Well, Arcandianos in 2007 in the Nutrition Journal aimed to determine just this. We have an understanding that our genetics may influence the metabolism of nutrients that we eat, like we may be better at metabolizing fats, like I mentioned in the previous study, where the indigenous people of Greenland can metabolize fat very well. Perhaps we have a higher requirement for B vitamins. Perhaps we have a lesser ability to store glucose for energy and therefore require more carbohydrates than other groups. This whole area of research is called nutrigenetics, how our genetics can influence our nutrition and metabolism. So in this study, the scientists aimed to see if information on genetics could help people lose weight. The scientists recruited people that had repeatedly failed at weight loss, and they were offered a nutrigenetic screening test in regard to genes that regulate metabolism. 50 patients were in the nutrigenetic group, and 43 patients served as controls. All participants were instructed to follow the Mediterranean diet, which is rich in olive oil, vegetables, fruit, beans, fish, and whole grains, but lower in dairy, sugar, processed foods, and red meat. Those in the nutrigenetic group that got the genetic testing were provided information on which foods they may need more of or less of, depending on their genetic variation for how they metabolize food. All the individuals were to eat with a calorie reduction with the goal of losing weight. And this study lasted for 300 days. So what were some examples of the specific suggestions in relation to their genetics? Well, for example, some of them had a variation in the genes involved in B vitamin folic acid metabolism, like for example in the genes MTHFR, MTRR, MTR, or CBS. The scientists recommended to these particular individuals to add a supplement containing 800 micrograms of folic acid, 15 milligrams of vitamin B6, and 20 micrograms of vitamin B12 in order to compensate for that loss of function allele. Some individuals had variation in their superoxide dismutase enzymes. Superoxide dismutase enzymes are free radical scavengers that have important antioxidant activity. So these individuals may have a reduced capacity for antioxidant activity. So the scientists recommended to add supplements containing antioxidants like 5,000 international units of vitamin A, 250 milligrams of vitamin C, and 200 international units of vitamin E. Some individuals in the study had variations in their angiotensin converting enzyme, or PPARG. This gene diet and gene exercise interaction with these genes have been reported to affect blood glucose and insulin levels. So the scientists recommended to stay on the Mediterranean diet, as it already was within the limits recommended for having lower carbohydrate or lower glycemic index, but they suggested for these individuals to exercise more in order to combat that potential negative effect on their blood glucose or insulin. Now, also as I'm reading this, I'm thinking I would love to get my genome tested to see which genes may play a role in my metabolism and health. And I might wind up doing that this year. I know that there are companies that can do genetic testing for allelic variation to see how that can influence our health outcomes and how we metabolize food and nutrients. However, I don't believe that there are any companies that do epigenetic testing, though. And that's one of the things that I talk about in today's episode, right? We're born with a certain genetic code, and that's determined by our ancestors over many, many generations. But our epigenetics can change much more quickly in the short term. It's very likely that our parents can influence our epigenetics and our outcomes and how that genetic code works. But I don't really think that there's sequencing for epigenetics just yet commercially available. But that would be really interesting. So regardless, what did the scientists find in this genetically guided weight loss program? Did the genetic testing, the genetic tailored diet help people with weight loss? Well, the results suggest that yes, it appeared to help. It appears that in the first 300 days of the intervention, both the nutrigenetic and control group lost comparable amounts of weight when they ate the Mediterranean diet. But where they seemed to differ more was whether or not they were able to keep the weight off. Now that's usually the difficult part, isn't? Maintaining the weight loss. Now, individuals in the nutrigenetic test group were more likely to have maintained some weight loss. In fact, 73% of them maintained their weight loss, but only 32% of those in the control group maintained their weight loss. So this is an example of how nutrigenetics, or information on how we metabolize nutrients, may aid in health outcomes, how we can change the destiny laid out for us by our genes. Now, how about we talk a little bit about mental health? Charles Darwin wrote in 1873 in the journal Nature, quote, "No one who has attended to animals either in a state of nature or domestication will doubt that many special fears, taste, etc., which must have been acquired at a remote period, are now strictly inherited. Other instincts may have arisen suddenly in an individual both of selection and serviceable experience, though subsequently strengthened by habit." Now, in this article, Charles Darwin talks about an observation in a group of dogs. A dog was observed to have a unique and strong fear of something. Now, they don't specify what that something was in the article, but just that there was a unique and strong fear that this dog had. But that feeling of fear appeared to be passed along to the next 3 generations of dogs, even though that father dog did not interact with the pups. It was suspected that the original dog experienced some trauma that was passed along to the later generations through genetics or epigenetics. Now, this begs the question then, can we see this in humans? If a trauma happened in an individual, can that fear or anxiety be passed along to the offspring? Could this explain why some individuals describe a fear or dread of something that they cannot explain? Maybe. For example, I remember my mom shared with me that whenever she hears a train whistle, that she has this feeling of dread and sadness. That it's a very strong feeling, and she cannot explain it. She can't remember a time when she heard train whistles and can't remember any certain experience associated with them. She just always remembers not liking them. Now, why is that? Was this conditioned early on in her life and she doesn't remember? Or perhaps, just maybe, an ancestor of hers had a tragic event occur with a train. Did that ancestor develop a deep fear, dread, or sadness with train whistles? And was this passed down to subsequent generations? Just like in this observation of dogs that Charles Darwin wrote about. Because we have certainly seen this in animals, as noted by scientists. It's an interesting thought, isn't it? Do you have any preferences, fears, or feelings about places, sounds, etc. that you can't quite explain? Now, not many human studies have been conducted on this, so it's hard to elaborate more, but there are a few related ones that I'll go into. For example, there are some publications on transgenerational transmission of trauma. For example, in Holocaust survivors who battled through severe trauma, it has been observed that there were some epigenetic changes to the genome that might be potentially passed down to their offspring. Deckel in 2008 in the American Journal of Orthopsychiatry wrote of this. For example, Deckel writes of war combat veterans battling with post-traumatic stress disorder, or PTSD, and whether or not epigenetically this can influence their offspring. So it is possible that traits for stress and anxiety may be perpetuated in future generations. Now, this is a difficult thing to study because perhaps individuals who developed PTSD already had this genetic or epigenetic predisposition of higher stress and less resilience. This has been seen in individuals born with an allele or genetic variation in the gene 5-HTT-LPR. Now, interestingly, this is the same gene that I spoke about a couple episodes ago when I talk about the neuroscience and psychology of happy and lasting romantic relationships. That individuals born with a specific variation in this gene seem to have more stress, less coping mechanisms, and less marital satisfaction and a higher likelihood for separation in times of stress. But as a result, it is difficult to ascertain if life experience specifically influenced their genetics and whether that was passed on to individuals. So this is certainly still an area of research with lots of questions. But nevertheless, what did Deckel conclude in this review? Well, many studies report that children of parents with PTSD do unfortunately report higher levels of stress, more conflict, and mood disorders. This could potentially be associated with some epigenetic capabilities or traits that were passed on to the next generation. But the authors conclude that, yes, epigenetic changes may be passed down from life trauma, but what was more impactful in their observations was the environment that the parents exposed the children to. Main mechanisms of direct transmission of PTSD-like behavior was projection and identification. What this means is they found that fathers battling with PTSD may have had difficulty regulating their emotions, and their attempts to mitigate their negative emotions led to a significant use of projection mechanisms where emotions like aggression, shame, and guilt were projected onto the children. So even though these findings are quite sad, it also gives us insight that the environment is more important for the outcomes of the children. So again, our genetics are not our destiny. Even if an individual had a life trauma, they can choose to create a healthy living environment for the children so as to reduce any negative outcomes on their well-being. So those epigenetic markers that might be passed on are not as influential as the lifestyle choices that we make today. So that is a wrap, my people scientist army. Some scientific evidence on genetic history, how the lifestyle and life experience of our ancestors may influence our genetics and epigenetics today. We have observed that things like the food eaten, the climate we were exposed to, physical exercise, life trauma may all result in epigenetic changes within ourselves that can influence how our genes work and thus overall our health and behavior. But these epigenetic changes can be passed along to other generations as well. So the choices our parents made when they conceived us, how healthy they were, what they ate when they conceived us, could have set us up for certain health outcomes. However, if you got anything from this episode, I hope it is that you can appreciate that we have the power to change our own epigenetics and therefore our health outcomes. And we can do this by exercising, by surrounding ourselves in a healthy environment, eating a healthy diet. And eating a healthy diet may be aided by genetic testing to understand how we metabolize our food, or even just by understanding our ancestors and the types of food that they have made to have to adapt to eat. So I hope that this episode was informative and interesting for you. If you enjoy it, then please give me a rating on whichever platform you are listening from. Tell a friend about the show, leave me a message letting me know what you thought. And if you feel extra generous today, you can feel free to buy me a coffee to say thank you for the episode, as I do not take sponsors nor take money for the show. The information on how to do that and how to buy me a coffee is in the description box below. So I hope you all have a wonderful 2 weeks, and I look forward to seeing you on social media and catching you for the next episode in 2 weeks' time. Bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.